day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we're going to be looking at Trigonometry paper 2, which is paper 2. And the trigonometry, you'll see in trigonometry we have plus minus 50 marks. So the exam marks in your paper 2 will be 50 marks. And it's a lot of marks. It's 1/3 of the paper. So we really need to work very hard to get at least the minimum that we can get through in trigonometry should be above 30. And this is exactly what we're going to be looking at and see how can we get above 30 out of 50 for trigonometry. Right. So the objectives of this lesson today is that these are things that we really need to know under the trigonometry. First of all, you need to know, when you're practicing, you really need to know the basic trigonometric ratios. This is the pre-knowledge that you need to know going into your exam. And take note that there are special names for the reciprocals of these trigonometric functions. So in other words, trigonometric ratios. So always you must know your ratios and also their reciprocals. You need to refer to special angles calculated. So now we need to also refer to the special angles and calculating them without using a calculator. Let's simplify the trigonometric expressions or equations with or without the use of a calculator. So you'll see that mostly we are required to do some of these things without using a calculator. The identities, we have these identities, and these identities, this formula will also be given there in the formula sheet. That's given in the formula sheet. All those ones are given in the formula sheet. We just need to know how to work with them. Right. Apply the reduction formula of 180 plus and 360 plus and minus. And that's plus and minus, and then also going to look at that. You must know how to do that. The other aim of doing this lesson will be to determine the solutions of trig equations. So we're going to be given an equation. We're going to do only the routine procedures, the easier ones. See. Now apply the sine and the cos and the area rules. The proofs are not going to be examined. So you don't need to learn the proofs. We just need, they are there in the formula sheet. We just need to know how to apply them and use them in trig area rules and cosine rule and sine rule. So we need to know how to use those formulae in there. Apply the trig identities studied earlier in the earlier grades. So that is in grade 11, where you need to prove that the left hand side equals to the right hand side. Those are identities. You need to solve problems in 2 and 3 dimensions by constructing and interpreting the geometric and trigonometric modules. Only numerical angles and distances, lengths will be used. So these are things that we're going to be looking at. So those are the sections that we're going to be looking at. Now, if you look at the next one there, it will be the parameters of the function. Remember, these are the functions that will be given to you, and then we need to also work with these functions, okay? The effects of P on these functions, you see now we have that, we are just going to add the P on that function. We're adding the P on those functions, but these ones here, you see we have a K and a K and a K, and there we have a K. So one parameter should be tested. So in other words, you're only going to get a question whereby you get only one parameter tested with the horizontal shift especially. The formula that are going to be used in this, as I've said, you must know your formula, and also the identities. This is a formula that is going to be given there, the sine rule, and this is the cosine rule that is going to be given, and we've got the area rule. So those three will be there. So remember, the sine squared theta plus cos squared theta equals to 1. As I said, this will be given in the formula sheet. 1 plus that, we need to know how to work with them, and that we need to know how to work with them. I'll show you in the following slides how we're going to manipulate them and how they're going to be asked in an exam. All right. Just to explain quickly some definitions on this. These are things that we have done in grade 10. If you look at the first sketch there, we have a right angle triangle. So in trigonometry, what are we working with? We're working with a right angled triangle when we do the definitions. So when we do the definitions, we are working with a right angled triangle. So remember, when it is not a right angled triangle, then we're going to use the area rule, cosine rule, sine rule to manipulate that. So now here, this is the y-axis, so that's why it's a y there. This is the x-axis, then we put an x. If I'm working in a circle, that line there becomes the radius, because if this is the center, that becomes the radius. So that's why we put an r there. So we are working in a unit circle. So you'll realize that the definitions, these definitions that are there, are the results are from this sketch here. So if I look at this sketch, the sine of theta is an opposite side over the hypotenuse. So my opposite side is the y value, my hypotenuse is the r. So remember, r is the line that is opposite 90 degrees. So once you know these basics, the trigonometry becomes quite very easy. So if you look at the cos is the x value with the adjacent side according to that. So the adjacent side, so I've taken this sketch there. So the adjacent side is this one, so it's adjacent, it's x. And the opposite for that angle, so it depends on where the angle is. You see the angle is there, and this is the hypotenuse. So the r is the hypotenuse, okay? So the tangent will be the y value over the r value. Now these three are the, what we call the reciprocals. So these are the reciprocals. So the reciprocal of sine, it's cos sec. The reciprocal of cos, it's sec. And the reciprocal of tan, it's cot. So if you've forgotten how this one works, you always, if I've got cosec of theta, I want to know which one is the reciprocal. I can look at the third letter. The third letter is S, so meaning that it will be sine. So if I'm looking at the cos, I always look at the third letter. Now the third letter in this one is C, so it will be cos. So if I look at that one, the cot, the third letter on the cot, it's T, so it will be tangent. So if you've forgotten, you can be able to do that, so that then you write it correctly. So this will be 1 over sine, this one will be 1 over cos, this one will be 1 over tangent. So if I put, I'm given the cosec, so I can write as 1 over the sine, and sec is 1 over cos, cot is 1 over tan. So once you know this, then, as I say, your trigonometry becomes very easy. Let's look at the reduction formula. So I'm just going through all this before we do the activities. Now, if I look at this Cartesian plane here, so you can see all ratios in the first quadrant are positive, right? The reason why they are positive is that the x value is positive, the y value is positive, the r is always positive. So all three here are positive. So if I take the sine of theta from this first quadrant, the sine of theta will be y over r, and both will be positive. If I take the sec of theta, the tangent of theta, it will be y over x, and the y over x, both x and the y are positive. Now here we're saying the sine and the cosecant, or the cosec, are the only ones that are positive. Why? It is because the y is positive, the x is negative, but the r is always positive. So all ratios that involve x will be negative. And which ones are those? The cosec, the cos, the tangent, and their reciprocals. They're both going to be negative. Why? It is because they use the letter x, and the x is negative. So everything that uses the y will always be positive. So the sine is y over r, so that's why it's positive in there. If we look at the tangent, we have x is negative in this quadrant. Remember we are taking the x values there, so the y values are also negative, the y values there, and the r is always positive. So which means if I take anything that has got an x in this quadrant will be negative. Cos has got an x is negative. The tangent uses both x and y. So if I need the tangent of an angle here, it's going to be a negative y over negative x, which obviously will become a positive. So that's why the tangent is positive in that quadrant. If I look at the cos, this side, x is positive, y is negative, r is always positive. So the only one that is going to be positive in this quadrant is cos, because it uses the x, and the x in this side is positive. Right. So now, when we look at the reduction formula, we look at this. So we look at both the ratios and the angle. So my angle here is 180 degrees. If I go backwards, it's a minus. Remember, angles are counted 0, 1, 2, 3, 4, 5 up to 90, 91, 92, 93 up to 180, just like that. But if I go backwards, then the 180 will be a minus. If I go forward, the 180 becomes a plus. Here, if I go backwards, it becomes a negative. I go forward, it becomes a positive. So I'm having an angle bigger than 180. So which means sine here will be positive, all will be positive, cos here will be positive, tangent will be positive here. So if I say, for instance, the tan of 180 plus, then the angle of tan becomes positive. If I say tan of 180 minus, the tan is not there, so it becomes a negative. Okay, so similar to the other quadrants. The pi, when we are working with pi here, we are working with 180 degrees. If I'm working with 2 pi, I'm working with 360 degrees. Very, very important to know that if you see pi in trigonometry, for instance, we know that we are working with 180 degrees. And the 2 pi will obviously be 2 times 180, which is 360 degrees. Right. With pi, it's when we are working with the radians. Okay, so now the next slide here. So remember, lastly, that all ratios stay the same. So if I want to reduce, and I want to reduce an angle, for instance, if I say sine of 180 degrees plus x, I want to reduce this angle. So I go to my sketch and check 180 degrees plus, it's in the third quadrant. In the third quadrant, only the tan is positive, so which means that the sign here will be negative. So I just write negative sign without this part, okay, without that part. So why am I putting a negative? Because the 180 plus falls in the third quadrant. The third quadrant, only the tan is positive. The rest are negative. So that's why we have a negative sign. When we do activities, I'll show you what we're talking about here. The identities, they are there in the form of sine and cosec. So they're in the form of a ratio and its reciprocal. So that's what I was saying, that if I've got a sine of theta, I write it as 1 over cosec. If I've got cosec of theta, I'll write it as 1 over sine of theta. All right. So same applies to that. You can see cos and sec, tangent and cot. The other ones which are quotient identities, the tangent can be changed to sine theta over cos theta. The cot can be changed the other way around, you see, so it will be cos of theta divided by the sine of theta, because the tangent and the cot are reciprocals. So that's why the other one is sine theta over cos theta, the other one is cos theta over sine theta. And here, the language that I'm talking about is the language of sine theta, not sine or sin only without an angle. If I write something like this, over that, we are going to get a 0. Right, so that does not mean anything, because remember, trigonometry is the relationship between the sides of sides of a triangle and also the angles in a triangle. So there must be a relationship there. So the relationship is that the angle is there. You see, the angle must be there. So if I say tan theta will be y over x. So the y over x is the sides and the theta is an angle. So trigonometry is the relationship between the angles and sides in a triangle. So if you don't have an angle and a side and sides, then you are not talking trigonometry, you're talking something else. Okay. Right, now the identities, square identities, the one that I've talked about, sine squared theta equals to plus cos squared theta equals to 1. I call it a famous one, because in mathematics there's the famous one. So sine squared theta plus cos squared theta, it's 1. So the others can still be 1, but they're not famous than the sine squared theta plus cos squared theta, because if I take this one, okay, that's what is done there. If I take this one that side, then I'll have 1 equals to sec squared of theta minus tan squared of theta. So can you see that is also going to give us 1. But the famous one that we already know is sine squared theta plus cos squared theta equals to 1. Similarly with this one, still gives you 1. But that is, so you must know those ones, you must know them. Okay, you must know how to manipulate them. In other words, you must take the other one to the other side, play around with them, and then that's how we're going to also set the question. Your questions are going to be set in that way. We were talking about triangles which are right-angled triangles. So now, remember in trigonometry we deal with a right-angled triangle and a non-right-angled triangle. When you see a non-right-angled triangle, then you must know that the rules, these 3 rules are going to apply. All right. So we cannot have a right-angled triangle there. We cannot have the sine of, say, B, it's equals to whatever, because there is an opposite side, but do we have a hypotenuse? No, we don't. So the hypotenuse is not there, because there's no 90 degrees on this triangle. So I cannot use the ratios. So never use the ratios when I have a triangle which does not have a 90 degrees. So that's where I'm going to apply this rules here. The area rule, I will only apply it when I'm asked to do so. So if they say find the area of this triangle, then I can be able to apply the area rule. Okay. This formula, you just need to know them. They're there in the formula sheet, just know how to apply them. To say if I've got a squared, the a squared is the side which is opposite angle A. The b squared is the b is the side which is opposite angle B. and the C is the side opposite angle C. So if I need to calculate A, I'll use the area rule, the cosine rule. When do I use it? When I'm given B, C, and angle A. So I must be given small letter B, small letter C, and this angle. Can you see? So I've got this side, this angle, and that side. If I need to find B squared, so B squared, so I'll use this side and that angle. So can you see? The A and the A must be the same. If I've got B squared, it means that it must be cos B. If I've got C squared, it means it must be cos of C. So they must be in that order. Okay. The sine rule is quite easy. It's the sine of A over A, sine B over B, sine C over C. This is when I'm looking for the angle. If I'm looking for the side, it will be A over sine A, B over sine B, C over, so I can swap them around. But I cannot swap one and leave out the other one. Okay, so that will not give us the right answers. Please. Right. Now, the type of questions that are going to be asked. So in other words, when you are practicing, the types of questions that are going to be asked. So you practice, one of the things that you need to practice is the Pythagoras type question using the diagrams. Sometimes the diagram is given, you just need to fill in some lengths and the angles on the diagram. Then we have, and this will also include the calculator work. So you must also know how to use a calculator. The next one is the reduction formula, which I also explained. We have the trig equations, which I'm going to explain when we do the activities. Identities I've already explained. The trig graphs, I've already explained that. 2D and 3D, this is where you're using the area rule and the cosine rule, and also the sine rule. So this is where you are going to be using this. Okay. With the trig graphs, as said, you're going to be either drawing the sketches or you're given the sketch and then you're going to explain. So when you do activities, you'll see what we're talking about. Now, the first part that I'm going to look at is the calculator work is quite easy. I did not put it in here. We just plug and play. That's all. You just substitute and get it and use a calculator to get to the answer. The first type of question that I'm going to do is the Pythagoras type question. Now, in this one, you're given a diagram. So I've done two types where the diagram is given, the other one, the diagram is not given. Now, in the first one, the diagram is given, and we need to answer the questions from the diagram. First of all, you are given the diagram in the fourth quadrant. So here is the fourth quadrant. Now, what do I know about the fourth quadrant? In the fourth quadrant, I know my x value, it's positive. My y value is negative. My r, it's always positive. Right? So now, in this case, I'm given the x value and the y value. And I don't know what is my r, but I must check on my given information. My given information says P is the point this and that. So which I said is my x value and my y value. It's a point in the fourth quadrant. It's also written there, it's a fourth quadrant. It is given that cos alpha. So the cos of alpha. How am I going to get cos alpha? It means that I must create a right angle triangle. Where I know my y is B, my x value here, I don't know what it is, or I know it is square root of 11, but I don't know what my b is and my r. But when I look at what is given here, cos is square root of 11 over 6, which means that the cos, as I know it, it's x over r, if I've got a sketch like this in a Cartesian plane. So which means that my x value is square root of 11, that's fine. My r value is 6, so I'm going to put a 6. What is it that I don't have? I have b. And what is this b? Is a y value. I don't know what it is. Oh, no, the question there that they already given me an answer. Show that. But that answer, I must still work it out. They're just guiding me. And I know with these questions where they guide you, you just immediately you write it down, and then from there you make it yours. It is not yours. You need to still work it out and see what the answer is. So how do I work it out? I'll say x squared plus y squared equals to r squared. Why do I use the theorem of Pythagoras? Because of the 90 degrees. Now the x value is going to be square root of 11. It must be squared. My y value, I don't know, it is b. My r value is 6 squared. Then I need to get the value of b. So the 6 squared is 36. Transpose the square root of 11 squared, which is going to be minus 11. Square root of 11 squared, it's 11. Then the answer that I'm going to get there is 25, which is b squared. I know that my b is the same as the y, so there must be negative. The answer must be negative. So I'm going to get the square root of b, which is going to be b, and then b squared. So I'll have square root of 25 plus minus. I get two answers here, but then I must then choose one because my y is in the fourth quadrant where the y value is negative. So this is 5. Right, so now b is equals to negative 5, and this is exactly what I got there. That's exactly what they want me to get. So I must work it out. I must not think that the b is already given is minus 5. So why should I work it out? I must work it out. I must show us how this person who was setting this paper saying the b is 5. So you must show that person that this is how we get to negative 5. Okay, right, now already we know that my b value here is negative 5. We know our r is 6. If I draw a right angle triangle here, I know that this is square root of 11. So now the question now says that I must get this by using the same sketch. Now the sec of alpha. Sec of, remember this whole angle is alpha, but I'm going to use it here. Because when we reduce it, we get the sec of alpha. Right, so now the angle here, it's alpha. The sec of alpha, remember, sec is a friend to cos, which means if my cos is of alpha is, so the cos of alpha is, this one is negative 5. So the cos of alpha is adjacent over a hypotenuse. So my adjacent side is this one, so it will be square root of 11 over 6 is the cos of alpha, which was given anyway. Now if I want the sec of alpha, I must swap this around, which means that my sec of alpha will be 6 over square root of 11. Right, now I now know what the sec of alpha is, which is 6 over square root of 11. Now I need the tangent of alpha. So I'm multiplying. So I like putting things in brackets. Now the tangent of alpha, tangent is opposite side over the adjacent side. So opposite is negative 5. The adjacent side is square root of 11. Then from there I can use a calculator to do that. Okay, or I can just multiply through. That's easy to multiply through. 6 times 5 is 30 with a negative. Square root of 11 times square root of 11 is 11. So I'll leave my answer like that. Okay, please don't put your answer in decimal form. Just hate those decimals. Yeah, please just put the answer in that form. Leave it like that. It's minus 30 over 11, and that will be the final answer to that. Okay, please do not get the angles. We're not interested in the angles. We're interested in the ratios. We are multiplying ratios, and we are using our sketch to do that. Okay, Same thing here in the same question, we're still using the same, so that one will be -5, that one is square root of 11, and that one will be 6. So that is my alpha. In this case, you are given the reduction formula, the sine of 180 degrees minus theta. What should I do first? I must first work out the reduction form, So 180 minus alpha is in the second quadrant. In the second quadrant, sine is positive. So we're going to ignore that and write sine of alpha. From here, then I can just go to my alpha and check what is the sine of alpha. So sine alpha in my sketch will be opposite over there. So my answer will be -5 all over 6, and I leave it like that. Okay. All right. The next question, still applying the same diagram, -5 square root of 11, 6. Now this case, in this one, they say show that. Once they say show that, it means that I must work it out. I do not need to write down. I know this is an identity. I need to work it out by using my numbers. So I need to use the numbers. So how do I use the numbers in there? So I'll then say the cosec of alpha first. Cosec is a friend to sine. Remember, I checked the third letter. Third letter is S, so it's a friend to sine. So my sine is -5 over 6, which means that my cosec will be 6 over -5. But in this case, it is squared. Don't write the alpha in. I've already got the ratio. Now minus. What is my cot? My cot is a friend to tan. So tan in that case was -5 over square root of 11, which means that cot will be square root of 11 over -5. And it's also squared. So remember, I'm working on my left hand side. I want to show that what I have here will be the same as 1. My answer here must be equals to 1. So 6 squared is 36. -5 squared is 25. Square root of 11 squared is 11. And this is 25. And then from there, I'll have 25 here. 36 minus 11. But I would prefer that you use a calculator. When you come to this step here, use a calculator, and that answer that you're going to get there will be 1. Okay, so therefore I can say this is the same as the right hand side, because the right hand side they're already given there as well. So I've shown that the left hand side will be equal to the right hand side by using that sketch. Obviously, it means if this value here is not correct, in the first question, you are already given that that number is -5. If you did not get the first one here, use that -5 that is given. Don't use yours, because you're already given that B is 5, -5, and maybe you tried to work it out in the first question, you did not get 5, you got 7 or something. Don't use the 7. Use the one that has been given to you. Okay, right, now that's type 1. Type 1, the sketch was given, no problem with the sketch given. Type 2 is when the sketch is not given, you must draw your own sketch. So they say with the aid of a diagram. You see, that means you must draw your own diagram. Now with this question here, it's a very tricky question, very tricky, but it's easy. Now they're saying you must just know your quadrants, that's all. Now they're saying the tan of beta is -2/3, right? Where the cos of beta is greater than 0. So which means I must draw my sketch. So my first sketch that I'm going to draw of beta, where is the tan negative? My tan is negative in the second quadrant and the fourth quadrant. That's where my tan is positive. But they say my restriction for that should be the cos in that quadrant that where the tan is negative. The cos is positive. So in this two quadrant, where is the cos positive? In the fourth quadrant. So my sketch must be in the fourth quadrant. Right? Because that's where the tan is negative, the cos is positive. So my sketch will be there. So the tangent, I know it's opposite, sorry. So the tangent is opposite, which is going to be a negative, sorry, and that over adjacent. So remember, tangent is y over x. So the y value is the first part here, the x value is the second part. But the one that is negative must be the y value. So the y value will be -2. The x value is going to be 3. So which means now I need to find the value of r by theorem of Pythagoras. So just to speed up that, it's 3 squared, which is 9, plus 4 squared, 2 squared, which is 4. 9 plus 4 is 13. So this one will be square root of 13. Right. So this number must not be there. Sorry. Right. Now, this is my angle of beta. Right? So I've got a sketch for beta, which is a complete sketch now. So everything that talks to beta, I'm going to go to this sketch. Right? Right. Now, the next one is, and sine of theta. I cannot put them on the same sketch, which means my sine of theta, I'm going to then draw another Cartesian plane. In this one now, it says the sine is positive. Can you see there's no negative sign? The sine is positive. Where is the sine positive? First quadrant and the second quadrant. But they say the angle must be between 90 and 360. So it must be between 90 and 360, which means that this quadrant will be out because I'm working from 90 right round to 360. So how many, where is the tick? The tick now will be in second quadrant. I'm going to draw my sketch in the second quadrant. Then my sketch will be in the second quadrant. In the second quadrant, I must put these values in now. The y value is 5 because it's y over r. Then I need the x value because the sine is y over r. Now the x value, if I work it out by theorem of Pythagoras, is 13 squared, it's 169, minus 5 squared, which is 25, and 169 minus 25 is 144. Square root of 144 is 12, but this side must be x equals to 12. Okay, but still you have to work it out. X squared plus y squared equals to r squared. The x value is not given. The y value is given. This is 169 minus 25, which is 144 x squared. So x will be square root of that, which is plus minus 12. Therefore, I choose x. It's equals to -12. Okay, we will have to work it out. Okay, but some I know you work it out in the question paper and then from there you bring it in. It's fine as long as it's correct. Okay, because you'll have only 1 mark. For working out this, you only have 1 mark. So you can work it out somewhere and then you bring it over and then it becomes 1 mark there. Now this is theta. That's angle theta. Now when I see the beta, I'm going to use the triangle with the beta. So if I go to this question here, it says 2 cot beta, so I'll have 2. The cot of beta, I go to this triangle. Cot is adjacent over opposite. You remember cot is in reciprocal to tan. Tan is -2 over 3. So cot will be the opposite of that. So it will be 3 over -2. Plus 1. So just use a calculator or just cancel out -2 and 2 cancel out. I'm left with -3 plus 1, so which is going to be -2. My answer will be -2. Easy. Then this one, the sine of beta, where do I go? I go to the triangle with a beta. This is a triangle with a beta. So what is the sine of beta there? The sine here is going to be minus 2 over square root of 13. So it's going to be minus 2 over square root of 13. Right. Multiply by the sec of theta. Now the sec of theta, so where do I go to theta? Sec is an opposite of cos. So the cos is minus 12 over 13. So this one becomes 13 over minus 12. Right. So because it's sec, so sec, it's the opposite there will be, so the hypotenuse first and then the adjacent. So now if I work it out there, I'll get negative times negative is positive. So the answer will be 26 over, if I multiply that, I get 12 root 13. Can just quickly simplify that. I think 2 goes in there 6 times, 2 goes in 13 times, so I'll have 13 over 6 root 13. Please don't cancel the 13 and the square root of 13. Those two will never cancel out. Okay, or from here, just take out the calculator. Then you do it with the calculator. If you do it properly, the answer that is going to be there will be different, but it will be the same. You can check it with decimals. Obviously, the calculators will always do your rationalizing of the denominator and stuff. Okay, right. Okay, the next part of work is the reduction formula. Also straightforward, easy. Now here, what do you need to do here? We need to simplify to a single trigonometric ratios of that. So in this case here, here's the reduction, here's the sketch whereby it's easy to use. If I'm practicing, I must always have this sketch in front of me and I'm practicing. The 180 minus 180 plus, then I'm going to write S, T, C, A. So first of all, I go to sine 180 plus theta, 180 plus, can you see 180 plus? It's in the third quadrant. There's a T, so meaning that the sign of that will be negative. So I just write negative sine x. That's all that you do. Then from there I go to this next one. Tan of 135. So the tan of 135. The 135 is in the second quadrant. In the second quadrant I use 180 minus. So what should be subtracted from 180 to give me 135? It's 45. But the tangent in this quadrant is negative. So I'll just write negative tan 45. Right. Because it's 180 minus a certain angle to get us to 135. Why did I choose 180 minus? Because 135 is in this quadrant. It's less than 180, greater than 90. Now in this one, sec of theta, I know sec is an opposite of cos. So, and 180 minus, the sec is negative. So which means that I'm going to get negative 1 over cos. Because already I know that sec will be negative 1 over cos. 360 minus is there. Cos is positive. I just simply write cos of x, which is positive. Then from there I'm done. So when we mark that one, this one, that one, we're going to mark it twice, and this one. So already we have got 1, 2, 3, 4, 5 marks out of that. Okay, so that's how we mark it. So we mark it for the changing of the sec and also for the sine. So now I'm going to have, this is cos over 1, so the cos and the cos cancels out. The tan of 45 is 1. You can use a calculator after that. Don't use a calculator on the 135. We will know that you have used the calculator. So now I'm going to have a negative, negative, negative. So my answer is going to be negative. The sine x is fine, it's that, and then that is 1. Obviously that is divided by 1. So the answer will be negative sine of x. So can you see I've simplified this to a single trigonometric ratio of x. Okay, These are easy questions that you must get. So yeah. Same applies to this question here, but the difference with this question is that we have a pi. You see, right? So the pi there, you always write it as 180, so it's 180 plus x. So 180 plus x is in this quadrant. The answer becomes negative sine of x. And the sec of x, it's in, we just simply write it like that. The tan of 180 degrees minus, then it becomes negative because it's in the second quadrant, divided by the sec of 360 is in the fourth quadrant. I just write it as a positive sec of x. 180 plus, it's in the third quadrant, cos it's negative in there, so I'll do the negative cos of x. And then from there, the last one is tan, which is going to be positive tan. Once I've put this, I can either change the sec to be 1 over cos, sec of x to be 1 over cos x, but I can simply cancel the tan and the tan, and simply cancel the sec and the sec, right? What is left now? I'm left with sine x over cos x. So the negative, 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 my answer will be negative. So I'll have negative. On top, I'm left with sine of x. At the bottom, I'm left with cos of x. Remember that sign is for everything. So it's negative sign times negative is positive. Divided by negative is negative. So they set to a single trig ratio. So meaning that that thing there, the sine x over cos x is tan of x. Then we still mark like that, 1, 1, 1, 1, 1, 1, then 1. So you can see we have a lot of marks on that question. You really need to know and understand that. All right, the identities, I'm not going to spend a long time on the identities. I know with the identities, they're quite a bit of a challenge also on the identities, but you must always be able to do that. Now with these identities, as I said, is a challenge. We can then use the left-hand side. Remember, when you're proving identities, you must have the left-hand side and the right-hand side. It's best that if you're doing identities, then you write down all your identities in there. In this case here, first I need to find the LCD or the LCM in this quadrant. So I'll have this and 1 minus cos beta. All right. Now, obviously this one divides how many times into this? It divides that one. So times 1 will have 1 minus cos beta. Plus, this is the plus sign. Now, this one divides into this whole thing there, it divides that. So times 1 will still be 1 plus cos beta. I love how they cancel out. Cos this and that, positive and negative, we get a 0. I've got a 2. Can you see now? I know my answer is going to be, I'm going to get the 2 as part of my answer. Then what is left there, I can multiply out now. This is the difference of 2 squares, so I only have 1 minus cos squared of beta. Because 1 times 1 is 1, 1 times this is minus, and this is a positive, they cancel out. This and that will give us a negative cos squared of beta. Difference of 2 squares is the same as a minus b multiplied by a plus b, right, which gives me a squared minus b squared. So it's the same thing, but what do I know? 1 minus cos squared theta is the same as sine squared theta. So that gives me sine squared of theta, of beta. Okay, now in this case here, I can either go and do the right hand side, which will give me 2 multiplied by 1 over sine. Remember, cosec and sine are reciprocals. So I'll have 2 times 1 is 2 over sine squared of beta, and that's the same as the left hand side. So I can prove that the left hand side and the right hand side are equal. All right. Right. So in the next one is basically the same principle that we're going to apply. I'm going to apply the same principle. So here the tangent must be changed. So if I use the left hand side, I can change the tangent to sine theta over cos theta. But then I'm adding it to something here, right? So now my LCM is still going to be, so the LCM will be 1 plus the same denominator that I'm having. Mostly you'll find that is the same denominator. So now the cos and the cos here, so I'm left with this. So I multiplied it with the top one, so I'll have 1 plus sine theta plus. Then this one and that goes cos, and then I'll have cos squared of theta. So now I'll have sine, I'm multiplying the sine inside the bracket. I'll have sine squared of theta plus cos squared of theta divided by, don't multiply out the whole thing in here, right? And then what do I see here? I'll see a famous 1, you see? So I'll have 1 plus sine of theta all over cos of theta into 1 plus sine theta. Can you see that that whole thing and that whole thing cancels out? Then I'm left with 1 over cos of theta. What is 1 over cos theta? It's sec of theta, which is what I need there. Okay, so it is how you understand your identities that can help you to prove that the left hand side equals to the right hand side. Understand your identities, understand the algebra that you're going to be doing, like your LCD and your LCM there. Understand that, and then these things will be quite easy. Don't just multiply out every time, just leave it there until the end. Can you see that when you are at the end of your answer, is then that you can see, this I can multiply out and then get the answer. Now the trig equations, it's one of the questions also between 3 and 5 marks, depending on how they're giving you the question. You have 2 types here that I've put here. The other one is when the ratio is given and you are given a value. The other one is when you are given a ratio in a ratio. In this case, when I talk about the ratio and the ratio, you might be given something like this, whereby this is a ratio, this is a ratio. The type 1 is when you are given maybe the tan of theta equals to maybe minus 3,5. When you're given this, so just divide both sides by cos, then I'll have tangent of theta equals to 1, then I can be able to work it out. The domain of this means that we're starting from 0 to 360, so not any other value. The reference angle is always a positive angle, so in other words, we must always use the calculator, using the positive value on a calculator. I'm not going to explain, this is what I was explaining, all this is what I was explaining here. All right, now let's get to the question. Now the question says determine the values of x if 3 tan x equals to this. So the first thing I'm going to do is to divide both sides by 3, so that I have a ratio on one side. Then I'll have the value, I think it's negative 0,177. We are working from 0 to 360. Now the x value, which is a reference angle, it's 10,037. I'm just writing all these numbers here, right? Now here you must write reference angle, because it is not your correct angle, it's a reference angle, because the tan is negative. Where is the tan negative? At 180 minus, at 360 minus, right? So it means that I always prefer drawing a table and say the first x value will be 180 minus my reference angle. The second value will be 360 degrees. Why am I choosing these 2 values? It is because on my Cartesian plane, 180 degrees plus tan is positive. 180 degrees minus tan is negative. Right? And 360 minus tan is negative. So tan is negative at 360 minus and 180 minus. So now that's 10,037 minus 10,3037. So I must subtract this. My x values, use a calculator, it's 169,9 degrees. 1 decimal. This one is going to be 349,9 degrees. So these are the two angles. If I take these angles and substitute them there, I'll get this value. Although with some decimals will be a problem with the last decimal, but we'll get closer to that value. Okay, because we have rounded off a lot there. Okay. Now the second type is quite an easy one also. It's when you're given the cosec, and on a calculator you don't have a cosec. So what do? Change it around to be a sec. You know the cosec, the third letter tells me that it's a sine, so it will be 2 over the sine of x equals to 2,563. So if I turn this around, the sine of x will be equals to, cross multiply and make x sine x the subject of the formula. The sine of x will be 0,7803 and all the other decimals. Now the x value, then I can use my calculator to get the x value, which gives me 51,29 degrees. But now the sine, the cosec is positive, so meaning that the sine is also positive. In which quadrant are they positive? 1 and 2. In quadrant 2 we use 180 minus. So this will be my reference angle. My two answers will be x in the first quadrant. I write it as it is. My other one will be 180 degrees minus 51,29. And that gives me 128,71 degrees. Okay, right. So this type of questions are very, 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 very easy. You have a calculator. You must practice by using a calculator. If you see cosec, just change it to 1 over sine. If you see sec, change it to 1 over cos. Cot, change it to 1 over tan. Because you're using the ratios in here to get to your answer. And know how to use your calculator. It's very important that you know. Know your Cartesian plane where you have your casts. Okay. All right. Now, the next part there is the trig graphs, which are also very, very, very important for us to understand. The trig graphs are very, very important. And you must get marks on the trig graphs, because one of the things that we lack is calculator work. It's calculator skills. We need to understand how to use our calculator. Now, and I know one of the challenges is that we don't bring calculators to class when we're supposed to where we're supposed to use them. We only bring them when we are going to write an exam, and then we find out those calculators are not working properly, and sometimes they are on radians, and then you're going to get all the values incorrect. So please make sure that you bring the calculator that you have used in class. Trig graphs are very easy. If you are requested to draw the trig graph, that's 7 marks or 6 marks. It's a bonus, because you just put those values on the calculator, then the calculator gives you if you put the x values, it will give you the y values, and you draw the sketches. Now these are the sketches that are going to be drawn. You're going to see in your exams. You know, y equals to a, where the a value it's your amplitude of the graph, right? And then you have your a there again, there. So the a that is at the back of the graph is the amplitude. The a that is next to the x is your period. So the a there is the amplitude. The a doesn't stand, it's not the first letter in the amplitude. The a there represents the amplitude, how high and how low your graph is. And the period of the graph shows you then how many graphs am I supposed to draw. If I've got a 2 here, I must draw two full graphs up to 360. If I've got a 3, I must draw 3 full graphs up to 360. Remember, our graphs are from 0 to 360. We don't want to see graphs whereby you draw a Cartesian plane and then you extend it to the left. We don't need this part. We always start from a 0 to 360 degrees. All right. The shifting of the graph, remember, if it's a plus, it's a shift to my left. If it's a negative, it's a shift to my right. Okay. Now we have the tan graph, which is a tan x, which is also a very important graph. Now, if I've got a q, which I did not explain now, the q is the stretch, is the stretch of the, so we are stretching that graph. So, right, if it's a +1, it means that I'm moving that whole graph up 1 unit. If it's a -2, it means that I'm taking that graph 2 units down. Okay, so in other words, if I've got that graph here, then from there it says +1 here, or +1. So it means that all the values that I'm having there will be +1, the whole graph. So my graph is going to be at 1 from +1, and so the graph is going 1 unit there and then 1. You see, sorry, so that must be above there. It must be above that graph. So I'm moving that graph up. So I'm just shifting the graph up 1 unit. Okay. All right. Now here are the questions here which you need to answer. You know, and that's what I was explaining here. If you look at these two here, you are given the two graphs f of x, then the function of x, it's equals to the sine of x plus 30 degrees. So the plus 30 degrees means that we have shifted our graph 30 units to the left. So in other words, the graph has moved 30 units to the left. The original graph has moved 30 units to the left. We have a g of x, which is cos x, which is a normal graph. The x is an element of 0 to 360, which means that my graph is going to start at 0, finish at 360. Now, the period of the graph means that if I look at g, the period of the graph here, you see we have a x is multiplied by 1. So meaning that we are drawing how many graphs? 1 graph from 0 to 360. So which means that the period of that graph there will be 360. Please do not write a lot of stuff in there. Don't write x less than or 0, between 0 and 360. No, the period of the graph is 360. Finish and class. So we just write 360. When they talk period, 360, depending on what that number that is there. What is that number next to x? Okay, right. So how do I then get the period of the graph? So the period of the graph will be the 360 degrees multiplied by that number that is there. So it's 1. So it's 360 degrees. If this number was 2, so if I had cos 2x, the period of the graph will be 360 degrees divided by 2, which is 180 degrees. So my period will be 180. The period of the cos graph and the sine graph are the same. They have the same period. Right. Depending on the number that is there. But the period of the tan graph, it's 180 degrees. Okay, so the period of the graph is 180 degrees, and then we have the period of the sine and the cos graph being 360 degrees, depending on the value that is given there next to x. Okay, now the amplitude of the graph is how high the graph will go. So where do we say we got the amplitude? We got it from the, sorry, here. So the amplitude is there. If that number is 1, it means that our amplitude of f will be 1. If that number was 2, then the amplitude will be 2. Can you see how easy we can get this mark? These are easy, straightforward marks that we must get. Okay, so here we are having our amplitude, we are having our period. So already in this graph we have got 2 marks for that graph. Right. The next question says you must take the 2 graphs and then sketch them from 0 to 360. Take your calculator, there's a table in there. Take a calculator, create a table. You see there's a 30 degrees there. So what you need to do is you have your intervals of 30 so that then you have a proper sketch. Because if I say 90 and 180 and 270 and 360, sometimes my sketch is not very proper. Okay, so now I'm not going to do all those values in there. All right, I'm not going to do all those values. I'm just going to do the basic one, but you must do all the values in there. So what do? I'm just going to show you an example what to do. What do? I take my calculator. I know you can use the table, but there are still learners who are still struggling on how to go to the calculator and put a table and put the function in, and then from there you have the, but your teacher must also help you with this again, so that then when you go to the exam you know exactly what you're doing. It's easier with a calculator, but I'm just doing it here because I don't have my calculator there. But this is what is going to happen in your calculator when you're using a calculator. At 0 degrees, so you take your calculator, will substitute your x by 0. So 0 plus 30 is 30, and it will find the sign of 30. In this case, you'll get 0,5. It will do the same and put a 30 degrees there. 30 plus 30 is 60. The sign of 60 is 0,866. Then we'll do the same with the 60. 60 plus 30 is 90, and sign of 90 is 1. Then it will repeat the process, I think with 0.866, and that will be 0,5, and then from there it will be a 0, and then from there it will be a negative 0,5, and negative 0,8, and negative 1, and negative 0,8. Can you see it's repeating again? And then 66, and then from there 300 it will give you negative 0,5, and then from there it gives you a 0, and it gives you a I think it's 0,5 in there, because that will be 390, so it must be positive. So now with the x is the same thing. The calculator will put a 0 there, and then the answer will be a 1, and a 0,866, and a 0,5, and again a 0, and negative 0,5, negative 0,866, and negative 0,5. Then we have a 0, then we've got 0,5 and 0,8, and we have a 1, I think, here. Okay, so I'm just going to quickly check. At 150 it will be negative 0,866. At that is going to be negative 1. Sorry, that should be negative 1. Negative 1. Then we have negative 0,866. Okay, and then at 240 it will be negative 0,5. And at 270 it's going to be a 0. Then we're going to have a 0,5. and a 0,866, and we have a negative 1. So the table is from your calculator. So you're going to have this from your calculator, and then once you have this table, you go to the next page, to the graph. Then you have your coordinates. So your first coordinate will be 0 degrees and 0,5. That's for your f function. Right, next coordinate will be your 30 degrees and 0,866. Okay, and just like that. So you put them as coordinates. Then from there you can just plot it as a coordinate. Then you have a proper graph. So how am I going to do that? So I'm going to go to my graph. Here the sketch will be drawn for you. So you don't have to worry with the sketch. The distances between the angles, it's the same. Because we know if we just say draw your own sketch, you find that the distances between the angles are not correct. And then from there, somebody writes a 1 here and then a 2 there. The spaces are not the same. So we give you this table, this Cartesian plane. So you just plot the points. The first graph there, we said it's 0. At 0 is going to be at 0,5. So 0,5 is a half. Right. At 30 degrees, we said it's going to be at 0,8. So at 30 degrees will be 0,8 somewhere there. And then at 60 degrees, we said it's going to be at 1. So it will be at 1. So just like that. So here it will be there, and then from there it will be at half, and then from there it will be at 0. Then from there it will be at 180 is going to be at a half. This is going to be there. You can see I'm drawing this, and it's going to be there, and then we're going to be 300. I think we will be at 330. It will be at half. Okay, so I think those values. Then 210 will be at negative 0,8, and then this one will be here, sorry. Then we'll have it here, and then we'll have it there, and at half, and then from there we'll have the at 360, it will be at 0,5. So then you just need to draw nicely, join these points and join these points, join those points, and then you have a lovely graph. There must not be an arrow on the graph. You see, so there must not be an error on the graph. Then I have a proper graph. But there's no child without a name. So the name of this child is F. So I'm going to write F somewhere or any other place there. But it must be on the graph. Okay. Then now I have my proper graph. And my boys and girls, this will give you up to, this is about 4 marks to draw that sketch. 4 marks. Okay, so if your points are correct, then you have the 4 marks. Now the next graph here is your cost graph, which I'm just going to put. So the first one there at 0, it will be 1, and then I'm going to use the 90 now. At 90 is going to be 0. At 180 is going to be negative 1. At 270 is going to be 0. At 360 is going to be 1. So I'm just going to draw it like this. Please don't do this. Just draw a smooth line here. I'm just drawing this to differentiate the two graphs. So this is the graph of G. So can you see I've got 2 graphs here on one, and I'm telling these 2 graphs the mark allocation is about 7. I'm just going to break down the mark allocation for you. The marks are for the x-intercepts, y-intercepts for the 2 graphs. The graph again is going to be for the turning points, and we also have marks for endpoints. Endpoints meaning that you don't have arrows. Once you have an arrow, we're going to give you a 0, because the graph it's from 0 to 360. It stops there. It doesn't go above 360. So we're going to give you that for the endpoints. Okay, so we've got the x-intercepts and the y-intercepts, the turning points of the graph. You see those ones are turning points of the graph, so we're going to give you that, and then from there we're going to give you for the endpoint. So we'll divide the marks into two, the F marks, the F graph marks, and the G graph marks. So you find that you have 7 marks out of that. Okay, so or 6 marks depending on the mark allocation there. So or 6 marks for that. Okay, so these graphs are quite easy. Calculator work, very important. You can do it one by one. You can do it one by one. Then and because you know you're going to get the 7 marks. You can take the graph of y equals to sine x plus 30 and start substituting. 60. You can start at 0, then you go to 60, you get to 120, doesn't matter. But then make sure that your points are not very far apart. You can substitute by 0 and then substitute by 180 and then substitute by 360. When you join those points, you're not going to get the bottom part. So that's my suggestion to you, that you use at least points that are much closer to each other. If you see 30, that just go with the 30s. You see 45, just go with the 45. You don't have you don't have 45, 30 and that, just use the 90 degrees, depending on how far you can go with your sketch. Okay. Now, sometimes the sketch is drawn for you. In this case, this sketch is drawn for you. Then we need to answer questions from this graph. So you see the sketch is drawn, questions from the graph. So the first question, the diagram below is given as that. Can you see that we have an A there, which is an amplitude, how high the graph can go and how low? Already the answer is on your sketch. And the sketch is from 0 to 360. So the first question obviously is write down. You see, they say write down. They say don't say calculate, write down. So meaning that look at the sketch, write down the answer. So that answer should be quite very easy. So the A will be 2 because the graph, how high can the graph go? Up to 2. How low is does the graph go? Up to -2. But the amplitude, it's not -2 because it's the distance between this. See, it's the distance of how high and how low. And those values must be the same. It's 2 units here. There's 2 units there. The distance, remember, we cannot have a negative distance. So the A value will be 2, not -2. Okay. B says sketch the graph of g of x. Now this one is f of x. We need a graph of g of x, and I'm given an equation tan of x. And I'm given, you can see I'm given 45 here and 135 and 225 and there. So meaning that with the tangent, you use the 45. It's much easier to draw it with the 45. First with the tan graph, what do I know? I know what I call the asymptotes. Okay. So now asymptotes of the tan graph, it's where the tan is undefined. So if I'm working on this and I go tan of 0, it will be 0. Tan of 45, it's 1. Tan of 90, it will give me undefined. Where it gives me undefined, I draw a dotted line through that line here, which means the tan graph will not touch that graph, that line. It's an asymptote. So it just goes up and up and up, closer to that line, but it doesn't touch it. Tan of 135, it will be -1. Tan of 180 is 0. Tan of 225 is 1. Tan of 270 is undefined. So where it says undefined, I just draw it. You'll get marks for drawing those lines because one of the mark will go for the asymptotes. Then it means that my graph is going to be starting this side and it must be like that. Please don't use a ruler for this graph. And these graphs have got arrows. Okay, I'll show you where the graph does not have an arrow. Tan of 315, it's -1. Tan of 360, it's 0. So this graph will start this side and go there, and then there it stops because we are drawing it up to 360. So if you put an arrow on this graph here, you're going to get a 0 for the endpoint. The shape of the graph, you're going to get a mark for the shape. You're going to get the mark for, even the previous graphs, you get mark for the shape. This one, I'm going to get the marks for the asymptote, mark for the shape, and mark for the x-intercept, which must be correct. So can you see how easy that graph is? And it's 4 marks. So the 4 marks is for the asymptote, and the other mark is for the x-intercept. Other mark is for the shape, and the other mark will be for the endpoint. Sometimes they don't give marks for the endpoint, but make sure that the endpoints are correct, because then they might subtract that mark from the shape, because your shape means that, you know, your graph stops there. Otherwise, if your shape then goes on and on and on with an arrow, it will not be correct. So make sure that the endpoints are correct. Okay, with the 2 graphs drawn, then they ask you the questions. With the 2 graphs drawn, then here are the questions that we must answer from the F and the G graph. So remember, we had an asymptote on this graph here. We had asymptote at the 270 degrees. Then we have that graph going that way and that graph passing through this. Then we had that graph going there, so stopping there. Right, so I've just drawn those graphs again. this one with an arrow, there's no arrow, so this is the G graph, and that one will be the F graph. Now write down the period of G. So remember, the G graph is the tan graph. So how am I going to write down the period of G? Remember the period of G? I said the tangent, the period of the tangent is always going to be 180 degrees. The period of the sine graph and the cos graph is 360 degrees, but the period of the tan graph is 180 degrees. Because for us to draw a full graph, we only need from 90 to 270. Can you see from 90 to 270? This is a full graph. This part and that part will form another graph, another full graph. If I connect this part and that part will form another full graph. So it is complete at 180 degrees. So from 90 to 270, it's 180, it's a complete graph. Give the equations of the asymptote of G. Can you see that question comes back again? After we have drawn that, they still give you marks for that. Where are the asymptotes of the graph? It's where x, remember this is the x-intercept, it's where x is 90 degrees, again where x is 270 degrees. Those are the only two asymptotes. Now I love the last question there, which says, for which values of x will g of x be greater? I love these questions. Greater than 0, meaning that the G graph is above the x-axis. So in other words, it's above the x-axis. Here's my x-axis. This part here is above the x-axis. This part here is below the x-axis. This part is below the x-axis. So I just want to find where is the graph above the x-axis. From which point to which point? So I can see it is from 0 degrees to 90. This graph is above. So I'm going to write from 0 degrees to 90 degrees, the graph is above the x-axis. Right? Where again is the graph above? From 180 degrees to 270 degrees, x will be less than 270 degrees, but it's greater than 180 degrees because it is above the x-axis. If they ask me about where the graph is below, it will be from 90 to 180, but 90 is not included. Ne? It is from after 90, then the graph starts. It's above the x-axis. So after 0 degrees there, the graph is above. So that's why there's no equal sign here. So you don't see any equal sign where I've put this. Okay, so the graphs are above the x-axis. The G graph, we're talking the G graph only. The F graph, no. If they ask me about the F graph, it will be above from 180 up to 360. It's above. Can you see? Okay, because that graph was minus, was y equals to the sign of x to be minus. Okay. Let's quickly go back. I need to rectify something there. Okay, right. So that graph is below it starts from below and up. So let's rectify this. So my a value will be negative, but the distance between the two there will be a positive value. If they ask me about the amplitude, a is -2. That's the correct answer. But if they ask me about the amplitude of the graph, the amplitude was going to be 2 because amplitude is distance, okay, between the two. So that should be -2. The a value should be -2. The graph is, you see, it's starting from below and then going up. Remember, the normal graph goes up, and then from there, and then it goes there, and then it goes there. There's the normal graph of y equals to 2 sine x. But this one is below, start by decreasing and then it increases. Okay, right. That should be rectified. Okay, now the last part of the work that you need to understand there is the 3D and the 2D problems. Now with the 2D problems, I've just put in the tips on how to tackle the 2D, 3D problems. That's where you have triangles which are not right angle triangles. So those are non-right angle triangles. Okay, non-right angle triangles. So that's where we're going to use the rules. So the first tip there is the sine rule is used when you have a known couple. Now the known couple that I'm talking about is the side of A given also the angle of A. So if I've got a triangle and I've got A, the angle must be given and the side must be given. Right? That's a couple. The cos rule is included when you have SAS. So in other words, with the cos rule you must have the side, the angle, and a side. So you must have SAS. So the angle should be there. So the side must be given, the angle must be in between the two sides. Okay. Now the variation of the cos rule is utilized when you are given 3 known sides. So even if I'm given 3 sides only, I can also use the cos rule to get an angle, one of the angles. Okay. The area rule also operates on this one. The area rule also operates on this one. You must first read the question carefully to see the link between the subsections and follow on. So the challenge with these questions is that the first question there, when you do the first question, the answer that you get in the first question, you must also use it in the second question. There's the challenge. Right. Now, let's look at the questions now. Now, the main cable configuration of a mobile crane is shown in the diagram below. You are given the sides, the AE is given, AD is given, the angle is given. So check everything that is being given. Do you have a right angle triangle? Yes. If I've got a right angle triangle, I can use the ratios. Once you see the right angle triangle, then you must know you need your ratios. Now the first question is ADE. How am I going to get ADE? ADE is this angle. It's in a right angle triangle, so it's quite easy. So I'll only use the ratio. Sine of angle ADE, it's equals to, sine is opposite over hypotenuse. So it's 7,5 all over 9.6. So for me to get ADE, what do I know? What do I do? Shift sine, and then I put these values in. Shift sine, I put 7,5 over 9.6, and the answer that I'll get there is 51.37. So that angle there will be 51.37, so I can get that. Easy. Okay, I've used the right angle triangle. Now the one, so it's 51.87. So now they want me to get BDC. BDC, so it's this angle here. But I know all these angles give me 180 degrees. So that's, I think this is quite an easy one, because I'm going to say 180 degrees minus the 51.87 that I got minus the 61 degrees. And the answer is 67,62 degrees. So I can get that angle. Is quite easy to get, because those angles they give me 180 degrees. I have this, I have that one, so that one 180 degrees. Okay, that one was easy. Now I have this angle here, it's 67,62. This one is 51,37. Now they want me to get the length of BD. BD, can you see BD there? BD, it's in this triangle. I check the triangle with more values. So now BD is in this triangle here, and I've got that angle, I've got this side, that angle, and that side. So BD is quite easy. I can use the sine rule. So I can say BD over sine of 78, because BD is opposite sine 78. Then I can use the one that I got here. So I can say 2,3 divided by sine of 67,62. So the sine rule can work now here to get BD. So just to manipulate this, I know how to do. You do that, you cross multiply, then you divide by the sine of 67.62. and then the answer that you're going to get is 2.43 meters. So I'm going to get, for instance, BD equals to 2.3 multiplied by sine 78 cross multiplied divided by sine of 67,62. Then the answer that I'm going to get is this one. So that it makes sense, my answer makes sense, because if this is 2,3 and it's opposite 67, the 78 will be 2.4, it will be more because of the degrees there. The last part, the last question here, I already know that this is 2.43, this one is 67,62, right? The question says I must get the length of AB. All right, so AB, I can see I have this side, I have this side. I'm working in this triangle. It's very important that you choose the triangle that you're going to work with. Remember, trigonometry works in a triangle. It will never work in any four-sided figure, in a triangle. In a four-sided figure, it means that I must divide that into triangles. Right, so now the AB, I'm going to then say AB squared. I'm going to use the cos rule. Why? Because I've got this side and that side and the included angle. Can you see? Then AB squared will be equals to 2,43, which is this side, squared, plus 9,6 squared, minus 2 times 2,43, times 9.6, cos of the angle. So the angle that I'm going to use is 61 degrees. Then you use your calculator. I'm not going to, please do not calculate this and then calculate that. Put everything in your calculator. Then the calculator will immediately give you the answer, 75,44. This is meter squared. So after I give you this, remember it's a AB squared, but the answer is looking for AB. So your AB will be equals to 8,69. Then it must be in meters. So 8.69 meters. And they say correct to 2 decimal places. Very important that you do that. And then you can say that, I think, will make sense, because if that is 9,6, that should be shorter at 8.61. Okay, right. So now this is the whole trigonometry that we have done now. It's 50. So when you're practicing, make sure that you divide all these sections and practice them per section. Don't practice the whole trigonometry. Practice per section and say, today I want to do Pythagoras. Tomorrow I want to do reduction formula. The other day I want to do that, unless if there's integration of those topics. But please separate them and then do them separately. And then you master a skill in one of them, and then you'll be able to can pass. As a bonus, anyone who can get this answer for this, then I can give them my ATM card, and there's the PIN code for my ATM card, and then you can go and buy yourself whatever you want. Please, you can give me a call. Thank you so much, and enjoy the rest of the day and practice.